record this session so people are aware, and we'll keep this obviously on file if people want to get the recording at some later date. So let me get started. So first of all, welcome everybody who's joined us today. Just introduce myself. I'm Tim Sargent. I'm a director at Morrison Water Services, part of M Group Services, and as a business and as a group, we get very much involved with kind of utility infrastructure and other assets. And clearly trenchless is something that we're very interested in as a business, but really from a personal point of view, and I think it's great to have Gordon here as a graduate. I actually did my final year project on trenchless technology when I was studying myself. So it's really great to be able to introduce Gordon here today as a young engineer with his enthusiasm for not only what we're going to talk about today, but for trenchless technology as a theme. So as a joint webinar today between UK Society of Trenchless Technology and the Pipeline Industries Guild. So it's great to bring the two together under the Green Alliance. So that's really good to see that collaboration. We've got a really interesting opportunity today to, as I say, actively engage in this event. Gordon is from SGN, one of the gas distribution networks in the UK, and we're going to learn today about I'll do the full term Robotics Roadworks and Excavation System, RRES for those who like the acronym. Gordon's background, he's been with SGN for 7 years, various roles, including his current role, which is Innovation and Tech. Sounds like a great role to me to be called Innovation and Tech, Gordon. I really like that. He has been involved with network planning, so he's worked at the sharp end and also design of mains replacement programs. So obviously he's got some experience on the practical end of this, which is really good. Chemical engineering graduate from Strathclyde. Hope I got that right, Gordon. And also proudly, he was formally awarded Young Professional of the Year 2021 through the UK STT with his passion for trenchless technology. So without further ado, Gordon, I shall hand over to you, and we'll get on with the proceedings. Thank you.
Thanks, Tim, for that. Thanks everyone for joining this session. Really excited to be talking to you about the Robotic Roadworks and Excavation System project. It's a really exciting time, and just a bit of background on myself. As Tim said, I was studying chemical engineering, and one of the big things that really all graduates and anyone working in the sort of industry sort of can take note of. But one of the really important things that at university I learned was how important sustainability is. One of the professors really focused on engineering graduates and all graduates, anyone in the industry, really have a responsibility to create a sustainable world. So the RRES really encapsulates all of those things, and it's brilliant to chat to you about the Robotic Roadworks and Excavation System. So today we'll go through sort of the SGN background, a wee bit of the portfolio of what's been worked on at the moment, which will hopefully excite you guys. And there's some really cool technology being developed, not just in the hydrogen space, which is a lot of focus on at the moment, but also in the sort of keyhole operations that RRES fits into. And then we'll take a deep dive into the actual RRES project, hopefully get you guys up to speed on what the different components and the technology behind RRES is, and show you some cool videos of some of the testing that's been done, and also introduce you to the plan of what the next steps are. So without further ado, we'll just move on to the first slide. So within SGN at the moment, there's sort of two arms that innovation are looking at, my team. And we're wanting to improve right now within the methane world. So removing paper, trying to get records digitized that will improve efficiencies, as well as reducing leakage on our sort of existing system. But there's also strategic innovations like the revolutionary stuff that we're going to talk to you today about, using satellite imagery instead of helicopters to monitor our transmission system, putting robotics in pipe, those sort of things that aren't just for the here and now, but also will help ensure a smooth energy transition for the future. And these benefits aren't just within the gas network, they're across the utility sector. And when you capture all of those innovations, all those new technologies coming in, hopefully we'll get to a point where we can evolve into a sort of green energy system, whether that's hydrogen in some places or heat pumps in other areas, just a whole system evolution with all the different technologies sort of working together. So that's the sort of strategy behind the sort of innovation department that I work on. And some of the actual projects that are in that portfolio can be seen here. So as I said, the satellite infrastructure in the top left-hand corner there in the yellow banner, it's really to get away from the helicopter operations. So we fly a helicopter every 2 weeks to monitor any encroachments on our local transmission system. Now, we think we can get a better solution, an environmentally prudent solution using satellite infrastructure, a bit of AI that would be able to negate the need to fly helicopters. And we're sort of looking into that as a feasibility and a testing project through the different technological readiness levels to bring that product to market. So that's an ongoing innovation that's been worked on as we speak. Within the purple banner, there's a lot going on within the hydrogen space, within the Energy Futures department. So there's a H100 project going on at the moment, which is turning offshore wind energy, putting it through an electrolyzer, breaking water, capturing that hydrogen, as well as capturing the oxygen that can be used in hospitals and things like that. Using that hydrogen then to heat 300 homes, and with the extension, once that's proven, to move into over 1,000 homes. So that's also been worked on in SGN, and the whole industry is trying to prove the safety case for hydrogen, which has got a big part to play in decarbonising our energy system. And then we've got a couple of these projects below, closer to implementation. So on the left-hand side, we've got a smarter governor system that will be able to reduce leakage, so control pressures much more accurately than what our current sort of technology is doing. So that's working on a smarter system when the demand isn't there at 12 o'clock in the day. We can decrease the pressures in a much more uniform manner. So we'll have a big impact on reducing our leakage when we have that sort of control system in place. And then the bottom right-hand corner there, stent bag, which is looking at basically an armband solution. If you imagine a deflated armband going into the system when we've got a gas leak, for instance, you put this deflated armband into the pipe, it would cover the hole, and then you sort of inflate it so that the pipe is sealed when we're in any third-party damage where it's hit our gas main. This system would allow us to seal the leak quickly so that leakage is minimised, but also secure supply downstream as well, so we're not having to turn any of our customers off in times of emergencies. And that's just 4 exciting innovations going on at the moment. There's a whole host of other things that are being worked on, especially within the Keyhole strategy. And what I'll do is I'll send out a link in the chat if you did want to check our annual summary out. And if you do have any questions, anything you want to find out, just feel free to drop me a line, or ask a question on Teams, and we'll be able to get some information. And one of the things at the moment is these innovations aren't worked in silos. SGN don't usually do these projects by ourselves. We engage with industry experts. So even if you've got an idea coming in, we're always willing to listen and see if there's value to be had to produce an innovation project. So that's the sort of portfolio, that's how it looks at the moment. So moving on to sort of our keyhole strategy. So we see a lot of benefits within keyhole surgery, as a lot of people in this room will see. Instead of using the butchering metaphor of trying to just get in and get out of the roadworks, getting to the main point of why we're there, whether it's repairing or replacing, the excavation is such an important part. Although it's not the reason why we're there, it takes up the most of the costs. Most of the injuries are down to excavation. So if we can move from a sort of butcher mentality to more of a surgeon's mentality, where we're excavating and with the smallest minimal incisions, we would not only be minimizing our carbon footprint, but there's safety and efficiency improvements that will come on to. So that's what we're trying to move to with sort of the keyhole strategy, and RRES is sort of the pinnacle of the technologies within our keyhole strategy. So as you can see, don't need to labour on the benefits of keyhole to you guys, but you would have on the left hand side, you can see the keyhole, the operative is above ground. It's safer for them. We reduce our excavation with smaller carbon footprint and minimise the disruption within the communities that we operate in, so we can get in and out a lot quicker with the keyhole operation. Whereas when you look at the sort of conventional way of how we used to do things, high costs, labour intensive, a lot of disruption to the public and the environment, and there is a higher risk of damage to assets, as well as our operatives' health and safety. So moving to a keyhole solution for as many operations as we can possibly do within SGN, within the gas industry, as well as the utility sector, not only improves our own company, but society, the public we operate in, and most importantly, our safety of our operatives. So that's the sort of big wins that we have. And we've developed a couple of technologies that have expanded the envelope that we can do. So within a keyhole, we're doing service connections. We can do mains replacement. We can do flow stopping, mains repair, camera inspection, and water extraction. One of the flagship projects was iCore, which developed the sort of service connection, allowing that to be done above ground. And when we add all that up, there's a lot of operations that we can do at the moment within the keyhole that the SGN are sort of doing as we speak. However, we can't do all of them. We're still having safety issues. We're still having cable strikes within the industry. And what we want to do is take a leap forward, and instead of minimizing these halves and cable strikes, why can't we absolutely eradicate them with RRES, for instance? So that's where we're sort of developing into the sort of robotic solution, and that's where the idea came from for this project, which is known as RRES. So the idea is to create an autonomous system that will be able to carry out a project. You wouldn't need any other teams. It would just be a one sort of solution, end to end, that would carry out all the excavation from scanning right through to reinstatement. A bit of the project background: so it's funded under the Network Innovation competition. We submitted a proposal to Ofgem for £7.3 million, and they accepted that in 2017. So we've been working on it since April 2018, and we've went through from an idea on a piece of paper right through to testing each different component, right on to integrating those different components, and now we're at a stage where we've assembled the prototype. Now it's on to trialling on dead assets, and then move to live assets. And the big benefits of this is, obviously, it's going to enhance safety, it's going to reduce our CO2 footprint, it will improve efficiency, minimise disruption, because it will turn a 3-4 day operation into a 1 day effectively, and it will lower the damage risk to assets in the ground due to its sort of central processing unit, which we'll come on to. And as you can probably see, the benefits aren't just in SGN, but across the utility sector as a whole. And also, we've had a lot of interest in the infrastructure and construction sectors, building houses and things like that, where sensing the underground is really important, and excavating that sort of area is vital as well. So a lot of interest across the industry. But as I said, we want to, at the moment, we're just trialing it. We're finding out what the use cases are for RES, and part of this today is hopefully hearing from you guys, from the industry experts, where you see RES potentially moving to as well, and broadening that envelope that RES could effectively to move to. So that's all the benefits of RES, and that was the sort of proposal that we submitted. So what RES actually does, first and foremost, it will scan the below ground network. So we use its sensing module to create a 3D point cloud of exactly what's under the ground. And with using machine learning and data analytics, it will be able to predict with high accuracy down to the millimeter where those assets are, and that's stored within its CPU. So any other action done for the excavation, any work in the pipe, any backfilling, its programs knows exactly where those points are. So any interaction and any movement from the robot is really accurate, and safety is maximised. So once it's scanned the road, it will then cut a keyhole from the road surface, and this is programmed by the operative on site. So it could be a core. If we can do the operation within a core, it could be an airplane window if it was a slightly big operation that we were trying to do. Any shape with the keyhole cutting is able to be done, which just broadens the envelope to what we were doing before, with that keyhole sort of surgery module, which is the sort of second part in the process. So once it's cut that keyhole and it's moved the road surface from the hole, it will start to excavate and vacuum out all the soil, all the dirt, through a soft touch excavation. So there was no contact with any of the assets. It's done through smart supersonic air nozzles, which it excavates the soil and exposes the pipe, and allows operatives now to start thinking, right, what do I need to do? Instead of the effort going in to excavate, they're actually thinking about, right, what's the best way of repairing this main, or spending time on actually the reason why they're down there. So once the asset is exposed, RES has the potential then to conduct works on pipe, and this is the real sort of opportunity that we're sort of presenting here today. At the moment, we've proven that RES can fit a top tee onto a pipe, but there's that can be expanded, and that's something that we're going to be looking at in the trial in the next few months, to see what other components could be added as a module onto RES that would allow value to be had. So for instance, when I spoke about stent bag, could we click stent bag onto this so that our operatives are away from these gas escapes, and we're sending RES in for these emergency issues, and it's able to excavate but also fit a stent bag onto the pipe that would be completely autonomous and allows operatives to carry out their work from a safe location. So that's a big development opportunity with actually what RES is going to do on the pipe work, which industry experts were engaging with industry experts already, and trying to develop other solutions that we've not thought of within the gas as well as other utilities. And then once it's actually conducted the work on the pipe, then it's on to backfilling using the soil that was vacuumed out. So there's no new soil coming in. This is reusable soil because it's stored within the VacX truck. We put that back in, and then we add the reinstatement module onto the robotic arm, and then it will flatten. And once that's then flattened, it will pick up the keyhole, put it back into place, and then move away within a couple of hours of operating, which at the moment there's a wee bit of disconnections from all these processes, and that's why operations can sometimes take 3-4 days and even longer. And that's what RRES is trying to do, bring all this into one operation. So that's the sort of high level view. We'll dive into these points and I'll show you some videos of actually working an operation. But here's a video, an animation of what RRES actually is. So if you think of RRES as just a really smart robotic arm on a electric track that allows it to be mobile. So if you imagine the Citroen Picasso advert was always what I hark back to, where it was able to pick up a door, but it was also able to be precise enough to write Picasso on the edge of the door, if you've ever seen that. So you've got that precision, you've got the 6 degrees of freedom within the robotic arm. So the repeatability would be is there for this system, and it's on a track X unit as well, so it can work in rural, but it can also work in urban environments as well. So that's the robotic arm. It's got the 6 degrees of freedom. It moves out, and actually what's under the hood is sort of its own chassis in the right, but those tracks are really important because that will allow it to work on rural and urban environments. All the electronics are part of the module, and the batteries as well are kept under the hood. And once, depending on when it's operation, it will be jumping the different modules, whether it's below ground or it's cutting the road surface, the VacX unit. It'll be just clicking them in, clicking them off whenever they need to. So that gives you a visual of what RRES actually is, and yeah, what the potential of that, having that arm in an unknown environment, whether it's rural or urban, that precision, that repeatability is just tremendously beneficial to what we're trying to do within the keyhole space. And it's been built in an open source robotic platform. So as I said, there could be modules that you're thinking of that could just click on and click off that would bring benefit, and we'd love to hear from them if you are thinking of any of those things. And one of the big things within the Green Alliance, we tried to design RRES in a sustainability head sort of frame of mind as much as possible. So we had the decision to make whether have it tetherless or tethered. So we went with tetherless, so it was a bit more practical, and how it would actually be powered was a big thing. And we designed a fully electric system that is completely independent of tethered, and can provide heavy duty construction work. So on board there's 16 lithium iron phosphate batteries that allows operation to be conducted for 8 hours, so about a day. And just again, it's building a sustainable, once it's minimizing the excavation, it's all that sustainability, but the hardware is actually powered by electricity as well, which backs up the sort of sustainability path that we're on. So that's just a point there within the batteries. And where we are today is, so we've done field trials in the US. We've done live demonstrations, we've done the full end-to-end operation. We've got a lot of good success from that asset mapping and roadworks. We've done excavations. We actually took it out on a sort of live site in New York, and got really good success on the asset mapping. And we've done sort of all the different tests, American side within our US sort of office, as well as one job on site on a live environment. And now we're ready to sort of bring it over to the UK and trial it on UK sites to learn from how the actual operation would work, tweak the system, because again, it is still a prototype. There's still a lot of learning to be had, but tweak the prototype. And yeah, before we actually sort of commercialize it and implement the solution. So a real big part of it was to develop the technology was the mock roadways. So we built a sort of mock roadway that would resemble a sort of typical UK infrastructure, all sort of all over each other, different sizes, different materials, and that was just so vital within the innovation process to understand, right, what sensor actually works well, what in their different environment, what needs to be tweaked, the machine learning, the algorithms that need to be developed to get to the point of knowing exactly where the assets are and where they, down to the millimeter. So that was just vital to create an iterative process of developing the best possible sensor package that we could actually possibly get. So the mock roadways was just vital in validating some of the technology that we were experimenting with. So onto the first step. So we'll take a wee deep dive into here. So the below ground sensing package. So what this actually does is it will click the sensor module, which is made up of electromagnetic sensors and ground penetrating radar. And what that does is it will move the robotic arm in a set pattern to allow the data to be captured accurately. And what we found was the sensors react in a way, in a much better way, if we actually have it periodically moving from left to right originally and then diagonally. And that just using it correctly and using it with that repeatability allowed us to confidently create a 3D model. So even though the sensor package, which is commercially available, what RRES does is repeats that sort of pattern and is able to create a 3D model of the underground accurately and with the repeatability that we would want. So just play this video of some of the stuff that I was talking about there. So you can see the electromagnetic sensor and the ground penetrating radar at the end of the robotic arm there. And now, full autonomously, the operator said, look, I want to scan this area within the computer, which is just off screen, which is speaking to the robotic system, and just clicks enter, and then that is now creating its pattern, moving up and down to get its first sort of scan of the ground. And the operator is just monitoring. So if you imagine the operator to the street to the left, or in a sort of cabin in close proximity to RRES, where they're just monitoring what's going on within the system. So it's done its first line of scanning there, sort of from left to right, which you can see. Now what it's going to do is a diagonal scan, and that, as I said, it just improves the accuracy of that sensor package, and then we're able to build up a 3D model of the underground. So just skip this on a wee bit. And this operation takes about 10-15 minutes to complete. And one of the big things with RRES is it's advancing technology in all the different subsystems. So this potential, we'll come on to, but this has the potential to be stripped out put that technology into its own unique independent system so that it can be brought to market a lot quicker, and that's one thing that we're working on as well. So that's the 3D model being built up there, and the algorithms, the computers actually trying to clean up the data based on feedback from the below ground sort of network. It's then able to look in its library and say, right, that was received from X amount of seconds, it had X amount of frequency, that must mean that it's plastic or it's metallic, and it's able to build up that sort of 3D point cloud in a much more accurate manner than what we currently are doing, because it's using that machine learning. And the operator can change the depth ranges to clean up the data and see where they want to start excavating. So before they start digging, they're able to determine where the least intrusive place is, where their pipe is, their target asset is, and then they can make better decisions of whereabouts they want to excavate. So that's the below ground scanning piece. And as I said, we've sort of stripped that data, that technology out, and created a sort of quicker to market solution. So RRES, we've still got a lot of work to do within the field trialing, but there's so much benefits with just having that scanning unit within the industry. So what we've done is we've stripped that technology out and created a sort of project with TfL called Inosmos, which is automated utility markup system. And we're moving from analog to digital. So if we wanted a below ground scanning network, it's normally a third party activity. It can be time consuming, it can be expensive. There's a lot of manual interpretation and transposing on the ground, and sometimes it actually has to go to an office to get tidied up, and that can take a long time to sort of get exactly the information that you're wanting to do. But with the solution that has been developed from RRES, we could potentially have a below ground scanning unit on a robotic platform. It would be a same day operation. It would be completed within an hour. It would use the ML to sort of mark up the underground, and then that data could be exported to sort of the data systems that we use, which isn't necessarily possible with some of the analog stuff that we're doing at the moment. And the concept would look something like this, where you could take that system, put it in the boot of your car the day before the operation, you just put that down, and then using the GPR, the processing unit, the EM sensors all in one, it's then able to detect and spray paint what the different assets within that area. So hopefully would be a lot beneficial to what we're currently doing.
Gordon, I'm just conscious of time because we've only got 20 minutes left. So if you want to get through your other slides, and then we can pick up some Q&A at the end, just so we've got 10 minutes at the end. Is that okay?
Sure, definitely. So yeah, just quickly go over these slides then. So cutting the road surface, just quickly show you the video of that. So once the system is excavated, it's cut, it's knows exactly where the assets are. The operative then decides where they're going to excavate, and then once they've clicked the size, they just hit enter, and then the system then cuts the sort of the keyhole out of the road surface. So we can just quickly see that. It then attaches the chainsaw, and then that takes about 40 minutes to cut the surface. So just speed that up. You can see there, that's the chainsaw unit, and it's just literally cutting the road surface based on the operative's input. Just skip these slides. So there's a lot of development. We went through a different prototyping, and we landed on the sort of unit that we've got there, which is the bottom right and as I said, it can cut any road's surface, and also the any sort of shape and size, which again broadens the envelope massively. So you see that airplane window there, from 600mm to 300mm, through rebars and things like that. It's all been tested, and really neat operation, trying to get that surgeon approach. So once it's cut the keyhole, it will then move on to excavating the soil from the keyhole. And one of the big things is, at the moment, VAC-X units, they are excellent. They're saving a lot of time and environmental benefits and safety. The only issue was with air lances. Sometimes operatives use them to interact with the ground, and that can cause cable strikes. So what we done was integrate the air nozzle into the excavator head, so they were taking out that manual operation. And these are some of the prototypes that we developed. And one of the big things with here is using supersonic air to pulverize the soil, so that we don't get as many blockages. And a lot of testing, FDR simulations went on to get the best possible design of the air nozzles, so that we can excavate much more efficiently. And then here's a couple of videos of different testing modules that we created. And this is sort of the testing results from the field trial that we done in America. So again, it's because the 6-degree freedom robotic arm is so precise that we're able to create the best sort of pattern, the most optimum pattern to excavate the soil. And literally just picks up the excavator module, we attach it to the vacuum excavator, and then we're able to bring up the soil and expose the asset.
I think I'll just ask one question while you're just keeping that. Was with that system, you said the operator sort of selected the initial position. Once it's in operation, will it automatically sense if and where the pipes are to work its way around the best optimum way of excavating? Is that something that's part of its intelligence, as it were?
Yeah, exactly. So it knows where that pipe from the below ground scanning knows where each different pipe is within the utility highway down to the millimeters. So it's able to avoid them going at different angles to excavate around those assets, and never come in touch with any assets within that ground. So all that information is saved in its sort of brain, and it's able to, it knows exactly the diameter, the height and the size of the end of the excavator head. So yeah, it can avoid all the it can avoid touching any assets.
Okay, perfect. Thank you for that.
Cool. So that's it, just moving there, and as you can see in the top right hand corner, all the soil's exposed, and we're actually then able to get to work on the reason why we're down there. The next step was fitting the installation. So this was just a proof of concept. Asking ourselves, can this system interact with the network? And what we done was we proved it through the fitting a top tee onto the network. So it scrubs the pipe using this module here. It will then electrofuse a top tee using the battery as power, and it can interact with the network. Now, this is just proving that the system can interact. Now it's about developing use cases that are going to bring the most benefit. So yeah, this is a big area that is under development at the moment. Okay, so it just scrapes the pipe, prepares it, and then it sort of fits the top tee. And then after that, it's onto the reinstatement. So you can see the sort of scrapings coming off, and then this top middle picture shows you the top tee fitted on it. So you would fit the top tee to the robotic arm, and then comes down. It knows exact from its brain, it knows exactly where that pipe is, how much pressure to apply the top tee onto that pipe, and then using an electrofusion system that's attached to the robotic arm, it's able to use the energy from the batteries to actually electrofuse that top tee onto the system. And this is it here, and it'll apply the same pressure. As I said, it's quite smart, where it knows exactly where everything is, because it's a 90 mil pipe, and it's with the top tee, it knows how much pressure to exert onto the ground, onto the pipe, so that the electrofusion can take place correctly. And that's it fitted, and then you can see just in that the box in where the operative's hands is at the moment, that's the electrofusion part, and it's using the power from the battery. So again, it's just a proof of concept to prove that this system can operate on the network. Now, what's the big use cases that we can look into that's going to offer our operatives, the industry, the biggest use case, the biggest benefit? So that's it, just coming down, and I think you guys get the point where it will just come down, exert the pressure needed, and electrofuse onto the network.
Right, thanks, Gordon.
And then on to reinstatement. So literally just vacuum all the soil back into the hole, put the keyhole back on top. So you can imagine that conventionally sometimes we'll use virgin soil coming back into it. You know, we won't be able to use some of the tar, so it's a massive operation to actually carry out the reinstatement. But this reuses the core, reuses the soil, and a lot of environmental benefits to be had within the reinstatement process. So yeah, it literally just, that's the compactor, just compacting the soil to this industry spec, and then the operative just brushes the soil in every so often, and that's basically, once that's all done, the keyhole can then be put back into place. So that's the reinstatement, and that's the full end-to-end operation. So if you imagine, that could have taken days, if not weeks, for us to do it conventionally. We can get in and out within a couple of hours, and yeah, hopefully a lot of benefit in the environmental side, but massive on the safety and disruption piece. So where we are at the moment, we've built and tested it in the USA. It's now at Epsom. It's now in UK soil, so we're starting trialing in the UK. Our first demonstration was last month. There is opportunity, if anyone did want to come and see, it's going to be at Utility Week Live and No Dig Conference in the next few months. But if you did want to see it live, it'd be good to invite you down to one of the demonstrations. So please get in touch if you did want to see it. Once we've done the trial and we've found out all about the benefits, then it's on to commercialisation and implementation. But a lot of that feedback and the learning will be designed from what we find out within the trials of the UK. So that's it there at Epsom, and we're going to be doing some end-to-end operation over dead assets, live assets, and rural environments, urban environments, just to see where the biggest use cases of RES is. And as I said, there'll be a lot of learning feedback to be had as it's a prototype. And then just lastly, the vision, how does this actually fit into the 21st century? Upskilling of and hiring the new talent. It should be a way of the old, where we're risking people's health and safety and things like that. So this is probably a really good step into the 21st century, moving into a digital world, that we can actually start using our brain to think of what we're actually there for, and instead of trying to excavate it, which is an enabler to why we're down there. So trying to move the operation is into the 21st century, and really want to hear from you guys where you think RES could provide value. And if you do, just feel free to get in touch with myself or David McLeod at ULC. The emails are there. And yeah, thanks for listening, guys. If you've got any questions, I'll take them now.
Okay, I think what we'll do is we've got 10 minutes left. So what I'll do is I'll try and summarize a few key themes that have come out, Gordon, from the questions. There's quite a lot of traffic, so we won't be able to do it justice in the 10 minutes we've got left. So I'll try and pick up one or two areas. I think one of the things, I mean, for me, first of all, and I'm sure for the audience, is the fact that it's almost like technology within technology. You've got your robotic system, and then you've got all these attachments. And I didn't realize until this presentation how detailed each individual element and what detail you've gone into for those individual elements, whether it be the pre-sensor or whether it be the actual vacuum excavation type of soft dig and so forth. So I'm sure a lot of people on this webinar have learnt quite a lot from that. And I also really like the idea that certain things you're also seeing as, do we pull that technology, you know, it's part of the robotics, but we can also use it separately. So that's really very, very interesting. So I'll try and pick up one or two things. One of the questions that was raised really is around that initial survey, the sensor. Have you adapted something that's existing technology, or have you really gone from scratch? And in going from scratch to actually locate the utilities, is it sensitive enough to understand different pipe materials, different depths, and then also, of course, this issue of things being in the way of each other? How sensitive is it? What detail have you gone to really sort that puzzle out for the sector?
Yeah, so what we felt to bring the product to market a lot quicker is we used commercially available products but tweaked them. So whether that was we had a whole sort of testing, looking at a testing procedure where we looked at commercially available products within the sensing world, industry leaders, and then really took off the sort of box, tried to understand what technology was behind them, make use of the actual data and sort of not hack into them, but use them for what they were intended. And with the robotic arm, with that repeatability and the precision, we were able to get a really high accuracy rate on a lot of the sensors that we tested, and the best ones were brought forward. So yeah, they're commercially available, and we made that decision based on, yeah, it's going to be quicker to market. In terms of the depths and the materials, the testing's been really positive, but we're building up that machine learning brain, so we need more data for us to confidently go in 100% of the time to say this is a 6-inch cast iron main, it's over a 2-inch electronic duct. But that's all going to be part of the sort of field trial, building up that sort of data library and machine learning model, which we're confident we'll be able to get. So yeah.
Okay, that's interesting. Another theme that came out, I think, and I think you pretty well answered this one though, and I think we'd all be interested in this with some experience we all have about excavation of different ground. Clearly, you know, one of the challenges is this type of unit good for certain ground in reality, a sort of sweet spot, or are you comfortable that it can cope with quite a variety of ground conditions, not only ground conditions, but maybe encountering material like reinforced concrete or bricks or things like that? Are you building that sort of adaptability into the way you're doing the soft dig element of it?
Yeah, definitely. So testing's been going on for reinforced concrete rebars. We've got this in mind for Scotland operations as well as London, sort of southeast, which is different materials and things. So it was good to get the feedback from operatives of what sort of soil types and ground materials that we see. So testing's been encapsulated into that, and the chainsaw works in quite a smart way that we've got a patent out for it, that it's able to detect rebars, or it's able to detect areas that is causing real friction, and the power then is increased based on that feedback. So the testing, yeah, that allows us to have a bit of versatility or flexibility on sort of easier materials as well as the hard materials with that feedback loop in the chainsaw.
And also, I noticed that you mentioned during the talk, and some people have also asked this question. You clearly done sort of improvements around the sort of vacuum excavation with trying to remove material again. One of the things I was interested in doing, I'm sure the audience are, is does this issue of the robot knowing where it is at any particular point in time, is that literally you could take the machine away from that site and then bring it back the next day and it would know where it was relative, you know, on a GPS system or some sort of satellite system? Is that how sophisticated it is?
Yeah, so it's not actually something I think we've tested it being taken away, brought back to site, but the data is stored. All it would need is a sort of locator on site. Maybe if you sort of shine it over the hole, and then it's able to pick up the asset, and then it's able to know where it is, in respect to that. But yeah, a lot of work went on in the algorithms and the environment, and able to for the robot to be able to work in an unknown environment. So there's a lot of sensors on the model that it's able to pick up where it is, and detect if anything was to come into that environment. It's able to reflect that within its CPU mind, and able to avoid any issues, if any things that were to go wrong, and pick up those things. So the sensors and the algorithms, it is stored. So that's how it sort of works in the robot, in the unknown environment. It knows exactly all its lengths and things. So it just sort of pictures with some really good videos of it being able to move around at the early stages using a thing called SLAM, which is a simultaneous localization and mapping. So that just is able to, those algorithms are able to allow RES to work in an unknown environment, that you can just shine it up. It uses its sensors, and it's able to move around safely. So yeah, a lot of technologies has been put into that sort of brain, the computer algorithm, so it can move around in the unknown environment.
Okay, I think that answers a number of the questions around the issues of encountering different things when you're doing the excavation, and likewise when you're backfilling. The other one, a number of people have sort of asked more around the practicalities of it. How big is this unit? How sort of heavy is it? You know, how mobile is it from the point of view of getting it to and from site? The reality of that, obviously, you're doing your trials in America, and we all know that roads are a little larger in the States. So again, is that something where you're, you know, you've got a particular size of unit in mind for a standard road width or half a road or whatever? You could just give us a little bit of practicalities around that.
Yeah, so the system was built for the UK. So we've managed to make it meet all the requirements for the UK roads. So it's 6 foot in length, and I think it's 2 foot across. And the robotic arm, once it's moved out, it then increases the length. But we can safely and comfortably use this on one road, by blocking one lane, sorry, within the road. And the practicality is one thing that we're going to learn so much on the field trial stage. How do we actually move this in and out of streets like London? Is it a flatbed, or is it a sort of unit that maybe gets dropped off, and then its supporting equipment gets dropped off when needed? So these operational processes and procedures are all things to be learned as part of the trial. So yeah, we'll have a better idea of how the things will work on a sort of procedure base after this trial. But yeah, definitely been designed in the sort of UK remit, and confident that it will be able to work quite discreetly within our roads.
Okay, I think that's a really good point, because I'm sure some of the people on this call have been conscious of that sort of American background and, you know, the reality of, well, when you come over to the UK, how's that going to work here? But it's really interesting to hear that almost like the baseline design has come from that practical viewpoint. I think there's still a load of questions we could ask you. I'm conscious of time. One last question, I guess, for you as an innovation and tech guy. And I would ask people, if you want more information, clearly particular questions, as Gordon has said, please reach out. His email's on the screen now, so please make a note of that and drop him a separate note if that's okay, Gordon. But the other one was resistance to even introducing this into operations. How have you, you know, in your role today, and I'm sure we're all curious about that, whether it be this technology or something else, how have you sort of gone about trying to bring sort of operations on the journey with you?
Yeah, that's definitely the most difficult part in my eyes. The technology development is actually the easy part. The implementation and the integration is actually the more time consuming, and the changing behaviour very difficult. So what we're trying to do is engage in sort of the user at the very early stage. So we designed a steering group for this particular project, which brought in Scotland and South operations, where they were able to add their feedback, create a sense of ownership, and actually have their input affect the design of the project, of the final design of the final project. So yeah, engagement at an early stage throughout the innovation is vital. Getting their feedback is not only helps with implementation, but actually benefits the product as well, which I've found. So yeah, there's pretty much a whole sort of there's a whole sort of project that we have to think about when we implement it. It's just not even half the battle once an innovation gets to that TRL9. Once it's available, it's the changing behaviour. But early development's really key. Getting buy-in from the actual user, getting their feedback is key. So there's a sense of ownership, and they've influenced the project, so it's going to be a lot easier on the implementation side. And then buy-in from sort of the operatives, from the different levels in the business. And one thing at the moment, this probably looks alien to a lot of people, but if we just keep harping at the benefits that this is going to create, not just to our operative safety, to society, to the public disruption, and hopefully they'll sort of be in line with the benefits if they're not initially see the sort of benefits with the technology. They'll be bought in with the benefits, so that can also help changing people's behaviour. But
And
yes.
just one last thing, we're a couple of minutes over, but one last thing. What do you need from the audience? Obviously, they can drop you an email, but what are the? I get the feeling you're still through this development phase. What sort of things do you need from, if you like, the sector to help you to further progress this?
Yeah, definitely. So we're still at the trial stage. This is a prototype. There's still development to be had. What we need to hear from industry experts, where you guys see the biggest benefits in this sort of technology would be, and then we'd love to sort of work with you guys and developing that. We're looking at it from a SGN point of view, but I think there's a lot of benefits to be had from a cross-utility perspective. So within the keyhole operation, trenchless technology, it'd be really interesting to see where you see RRES or where you see the different subsystems, and if you do want to propose that or speak to us on that offline, then we'd love to hear from you.
Great. Well, I'm sure I can represent everybody on this call. I found it really fascinating. You know, you read a few articles about this piece of kit. I've seen them myself, but I think the most interesting part of this is the technology within it. You know, those different stages where you've really gone into quite some detail about the individual elements and the whole process of what we have to go through to either repair or replace our assets underground. So, Gordon, I think it was a really interesting presentation. Thank you for putting the effort in. I know these things don't happen overnight, and and there's a few hours graphed in the background here. So really very much appreciate that. I'm sure we found it very interesting, and I'm sure again, as societies involved within the sector, we'd be intrigued with some sort of, you know, almost like an RRES update at some point to see when you move this into the streets of the UK, what does that look like and how does that feel? So yeah, that'd be great. So thank you everybody who's participated today. It looks like we're getting quite a few hands up and thumbs up and what have you, so that's brilliant. And we look forward to seeing you on the next webinar. Thank you.
Awesome. Thanks, guys.
You just want to hold